the velocity of the wave when the amplitude is constant, then the velocity also is said to be a constant. We have the displacement equation as y is equal to a sin omega t minus kx. K lambda is said to be considered as 2 pi because after every 2 pi this changes as the same value. So what is that period of oscillation? It is time taken by a particle to complete one full oscillation. Hello everyone, I'm Brinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to the session 2 of chapter 15, and chapter name is Waves. So in today's class, let us discuss regarding the concepts of the progressive wave, wherein in session 1, we had discussed regarding the introductory concept of the chapter 15, that is waves. So today, let us go to the progressive wave. So what is meant by a progressive wave? So in progress, meaning that is the term progress itself says that the one which goes forward, that is the one which continues its flow. So progressive wave means it is a disturbance which is caused. So here the progressive wave can be defined as it is a disturbance which propagates continuously in a medium. So for a wave to travel, it requires a medium. So there is a propagation of certain wave which is continuous. That is the disturbance created continuously in a medium. That is, it is said to be a progressive wave. And this wave which is continuous is having a constant amplitude. Amplitude means it's the height about the mean position. So let us study a few of the characteristics of the progressive wave. So what are those characteristics which are given point-wise over here? That is, the wave is propagated through the medium by the repeated and periodic vibration only if it has a repeated disturbance and respective periodic vibration, the wave can be called as a progressive wave. So here the periodic vibration of the particles in a medium is about their mean position. So what is the mean position? If this is your position axis and if this is your time axis, the wave whichever is showing a progressive, that means it continues further with the constant amplitude always, and this is said to be a mean position or equilibrium position. So when it is this case, the wave which is propagated through a medium, it will have the continuous movement as well as the periodic vibrations, and the periodic vibrations, that is the vibration of the particles, is about their mean position. So this is said to be the mean position. So that's all about the first characteristic whatever we studied under progressive wave. So now let us go to the second characteristics of the progressive wave. So what does it say? It is like there is transfer of energy. So when the particle is said to be moving in a medium, what happens to the energy of one particle? It is pushed to the other particle. That is, the energy which is associated with one particle is getting transferred to other particles. So there is a transfer of energy in the direction of propagation. It is always in the direction of propagation, and energy is transferred from one particle to other particle. So that's all about your second characteristics. Now let us go to the third one, that is the wave propagates with a constant velocity. The velocity of the wave, when the amplitude is constant, then the velocity also is said to be a constant. And this velocity of a wave is said to be a wave velocity, and the wave velocity is different for different particles. Each and every particle exhibits the different velocity at different instants of time. So that is all about your third characteristics under the progressive wave. Now let us go to the fourth one, that is all particles. The particles which are present in the medium undergoes this wave, that is the disturbance, and it is said to be a progressive disturbance. So here all particle vibrates. How does it vibrate? It vibrates with the same amplitude and same frequency. It has got same amplitude as well as same frequency when there is a vibration. I hope you're clear with the amplitude definition as well as what is meant by frequency. This definitions, that is the understanding of the basic terms like amplitude, wave velocity, frequency, time period and all were discussed in the session 1. So if you don't know, get back to the session 1 and come back again with the same characteristics. So here all particles vibrates the same amplitude with the same amplitude and the frequency is said to be one and the same. Next is different particles vibrate in different phase. So the particles are having different phase. So each and every particle vibrates at the same time in a different phase. No two neighboring particles will have same phase. So that's all about the progressive wave. And progressive wave, it is a normal wave whatever we study, that is the disturbance which is created and it is in the form of a continuous motion. So when this is a case, it undergoes reflection, refraction, interference as well as polarization concepts of light. So now let us move to the displacement. Let us study regarding the displacement relation. In what wave? In a progressive wave. So what is a progressive wave? It is the disturbance which is created under constant amplitude and that disturbance is said to be continuous. So here, in case of displacement in a progressive wave, we have got two kinds of graph. That is, let us consider figure A as so this position is said to be y displacement and this is your origin, this will be x and this will be y axis. So in case of figure B, we have the other figure which gives the graphical representation, that is the wave representation in the other way. So here we have O origin and O to P. The displacement is said to be x and the displacement over here is said to be y at certain point. So we all know that the progressive wave is a wave which causes disturbance in a continuous manner. So this progressive wave or a transverse wave, usually it is given in terms of a sinusoidal wave, that is a sine wave. So this is a representation of a sine wave. So what will be the wave equation with respect to sinusoidal wave? It is given as the displacement y is equal to A, that is the amplitude, sine means sinusoidal wave, and omega and t. Omega will be the angular frequency as well as t will be the time which is taken for a wave. So here we have got this wave equation and now we know that there is a particle which is undergoing a wave motion, that is the particle in a medium is undergoing wave nature. So when this is a case, at O, what is the displacement of the particle? It is considered to be y. Okay, so here we have at O, from O to P, what is the displacement of the particle which is taken, which is given over here, that is x. Okay, and from P to, that is the vertical direction about the mean position, what is the displacement? It is y. So we know when a particle travels from O to P, the displacement it is undergoing is x with respect to certain time and we don't know what time exactly it is. So we retain the variable as it is, that is time t. So how can you calculate the time period, that is the time of a particle to move this displacement, and that is given by, well, since we know that velocity is equal to distance by time taken, we can write it as time is equal to distance by velocity. So time is given by t and distance is nothing but the displacement which is undergone by the particle will be x divided by v, that is velocity. Just interchange your velocity as well as time. So we know that at O and at P, the particle vibrates and that vibration at the initial conditions can be given as t minus x by v. So this is the condition when the particle vibrates at O or else at P at earlier time. The displacement of the particle at P at time t is same as that of the displacement of the particle at this position O at time t minus x by v. So this can be equated. So this is said to be equation 1 and this is said to be equation 2. So you can substitute equation 2 in equation 1. You will get y is equal to a sine omega, and what is the value? T minus x by v. Now we are considering the movement of the particle, that is the vibration of the particle at t minus x by v, that is when the particle is at the position O. So that gives you the displacement of a progressive wave. So we have got y is equal to, further simplification, you will get sine omega into t minus omega by v into x. Now we can consider this omega by v, that is angular frequency to velocity, is said to be constant k, whose equation can be written as y is equal to a sine omega t minus omega by v becomes k and x. So this is said to be the displacement relation of a progressive wave, or else it can also be called as equation for a progressive wave. So having these, we will have to give the terms. Those terms are where a is said to be the amplitude, omega is said to be the angular frequency, t is the time, k will be the constant term, which is equal to omega by v, and we have x is nothing but the displacement of a particle. So here we have all these terms, like what does A represent, what does angular velocity gives, time, k as well as x. So that's all about the equation of a progressive wave. Now let us go to the amplitude as well as phase relation, that is the amplitude as well as phase. So you know that the displacement of that is the displacement equation of a progressive wave can be given as y is equal to a sine omega t minus kx. So this is the displacement equation for a progressive wave, or else it can also be called as equation of a progressive wave. So in this case, you all know that a sinusoidal wave is the one which lies between +1 and -1 and amplitude of +a as well as -a. These are the amplitudes as well as the values of a sinusoidal wave. When this is a case, we have the displacement equation as y is equal to a sine omega t minus kx. How are we getting this? That is by having a equation y is equal to a sine omega into t minus x by v, that is the vibration of the particle at certain interval of time. This is the concept. Having this concept, we have y is equal to a sine omega and t comes along, that is omega t minus omega by v into x. So this omega by v is considered to be k, which is this equation which is above. So now just considering this term, it is considered to be the phase omega t minus kx. So this is considered to be the phase of a wave, the one which represents the phase of a wave. So at initial condition, okay, at initial condition, that is when t is equal to 0. So when time is equal to 0, what happens to the displacement? So x also becomes 0. When t is equal to 0 and x is equal to 0, what happens to the initial phase? Initial phase becomes is equal to 0, because when you term t as 0, that when time is 0, its displacement is 0. So both the term becomes 0. So phase is said to be 0. So when this is the case, you will have the equation as y is equal to a sine omega t minus kx, and you will add up the phase whose symbol is psi. So this is the phase whatever is there over here. So when t is equal to 0, x is equal to 0, you have got the phase to be 0. So when the phase is 0, you can consider this term as 0. So that's all about your amplitude conditions as well as the phase condition. So now we are going to wavelength as well as the angular wave number. So we have got a wave as sinusoidal wave, and this is said to be O, that is origin. So this represents the time which is to be taken, and this represents the displacement. When this is a case, you have got the equation of a progressive wave as A sine omega t minus kx plus psi. So when this is a case, when t is equal to 0, what happens to your psi? It becomes 0. So the equation becomes y is equal to a sine, and you remain with k and x, and this is the equation whatever we have right now. So you know that every 2 pi value, the value after 2 pi continues the same thing. So that is, if this is a circle, this will be 0, this is 90, this is 180, again below it is 270, again it comes back to 360. After 360, it is same as that of 0, and it comes back again. That is, this periodic cycle keeps on changing. So suppose if you just finish off in your class hours, if you just finish off your assembly at 9 o'clock, again after 24 hours, it's the same thing, that is same the next day at the same time it is assembly itself. So when that is the case, after every 24 hours there is the same conditions which is repeating now and then. The similar case gets back to the wave, that is the sinusoidal wave, it's a sine wave. So here in this case you have got that constant term can be given as k lambda. So when this is a k lambda, so we have to consider what is that k lambda. After every number there is a repeating periodic activity. So when that is the case, your k lambda is said to be considered as 2 pi, because after every 2 pi this changes as the same value you people get it. So it can be written as k lambda is equal to 2 pi, where k is equal to 2 pi by lambda. So this will be the value of k, and that is all about your wavelength as well as the angular wave number whatever you get. So this concept is clear now. Now let us move to the concept, that is period and angular frequency as well as frequency. So what is this period, angular frequency and frequency? In this case, we have the same equation, and that equation is nothing but the equation of a progressive wave, that is A sine omega t minus kx. So this is the equation of a progressive wave, and we know that how the progressive wave is represented. So here we study about the period, angular frequency as well as the frequency, its relations. So here we have the progressive wave equation. How can you go with it? So when at certain time x is said to be 0, so the displacement at the origin is said to be 0. So when that is the case, you can just delete this. So it becomes 0 when x is 0. You have it as y is equal to a sine omega t. So we have to introduce other concept, that is the period of oscillation. So what is that period of oscillation? It is time taken by a particle to complete one full oscillations. That is said to be the period of oscillation. So when that is the case, you will consider let t be, that is let t be the period of oscillation or the time taken for one complete oscillation. So how can you rewrite this equation? Let me consider equation 1, and you can rewrite this equation as y is equal to a sine omega t plus the capital letter T, which suggests the period of oscillation. So now let us write y is equal to a sine omega t and plus omega capital letter T. So what does this sequence give you? So it is nothing but the value of sine repeats after every 2 pi change. So when that is the case, you can just give this omega t, which is equal to 2 pi as the previous one. So omega t is equal to 2 pi. So what happens to the frequency omega, which becomes 2 pi by t. So this will be the angular frequency and time period. So you know that the frequency is always the reciprocal of the time period. Since frequency is equal to 1 by t, what happens to the value over here? You can give it as nu is equal to 1 divided by this t can be written as t is equal to 2 pi by omega by interchanging these two. When that is the case, the below term becomes 2 pi by omega. Your omega goes up, so nu becomes omega divided by 2 pi. So this is the concept, that is the relation of this period, angular frequency as well as the frequency. So that's all about this concept. Now we are considering the speed of a transverse wave. So speed of a transverse wave on a stretched string. So in this case, we are checking out the speed of a transverse wave particles, that is the particles which is moving in a medium in a stretched string. So when a string is stretched, what is the force which is acting on a string? It will be a tension force. So it is called as a tension which acts on a spring, which is given by T, and it is always applied mass per unit length, so it is given as m. So there is a presence of tension as well as the mass m. So how can this be given? The tension and mass can be given, that is related to the speed, as the velocity v square is proportional to the tension on the string as well as the mass m. So when this is the case, removing the proportionality, you get a proportionality constant. So your v, that is the speed, is equal to root of T by m, whereas your constant is determined by c. So you consider your proportionality constant to be equal to 0. So when this is the case, you have got V is equal to, C is said to be 1. So V is equal to root of T divided by M. That is the tension per unit mass. So when this is the case, this can be considered as the speed of a wave on a stretched string. So this will be the equation in order to determine the speed of the wave in a stretched string. That is a transverse wave's speed. Okay. So where V is its speed, that is a velocity, T means it is a tension, and M is a mass. V is said to be velocity, your T is tension on the string when it is stretched, and M is said to be mass. So that's all about the concept of the speed of the transverse wave on a stretched string. So in today's class, we have studied regarding about the progressive wave and its characteristics, as well as certain relations, that is the displacement of a progressive wave and amplitude and phase, likewise certain relations of the displacement of a progressive wave. Then later we had studied regarding the speed of a wave in a stretched string, that is the speed of a transverse wave. So that's all for today. Let us all meet in the next class with different topics under the same chapter. Until then, have a good day. Thank you.